In this lecture, we are going to begin discussing the maximum subarray. So the maximum subarray is going to be finding the subarray that is at least one value which has the largest sum. So, and the one rule to this is a subarray is a contiguous part of an array. And if you don't know what that means, I will explain it in just a second. So, let's imagine we have an array with -2, 1, -3, 4, -1, 2, 1, -5, and 4 again. So this is our array. Let's split up our values. So a subarray is a contiguous part of an array. So that means that the values are in order, right? So -2 to -3, that's not a subarray because you skipped over the 1. So 2 to 1 would be 1, 2 to 3, 2 to 4, 2 to -1, and so on and so forth, all the way over here to the end. So what we want to do is find a subarray in this array which is at least one value with the largest sum. So there's a couple of different approaches that we can look at, but let's try to do one of the most efficient, and let's go with the linear solution. So we're going to look for the linear solution. And what we'll do is we're going to start at -2, and so obviously we have -2 here. So we have -2, and then if we go to 1, so if we added 1, well, we're still at -1, but 1 is obviously greater than -2, so there's no point in even worrying about that -2. So we'll just go ahead and discard this value because we know that it doesn't make sense to start there if 1 is already greater than that 2. So we'll move our index over to here, and now we're starting at 1. Okay, well now we have a -3, so we'll add plus -3, which means we are at -2, and now we're at -4. So now we have plus 4. Well, 4 again is greater than -2, so it doesn't make sense to start out at this 1 and then add in this -3. So we have another negative prefix. So we'll just go ahead and discard all of these values because it doesn't make sense to include them when we can start out at 4 right here. Okay, so we start out at 4 now, and we add 1. So we say plus -1. So now we're at 3. So we bring down this 2. So now we add 2, and now we're at 5. Bring down the 1. Now we're at 6. And if we bring down this -5, now we're at 1 plus 4 is equal to 5. So even if we did this entire subarray, we see that our greatest value here is 6. So for this array, our longest contiguous subarray, or excuse me, our longest subarray, so our maximum subarray would be 4, -1, 2, and 1. And this would give us 6. So we don't have to worry about any of these other values here. So in this case, we are done. So if we look at this, there was a common kind of theme that we were looking for. So we were removing negative prefixes, right? So what does that mean? It means that it doesn't make sense for us if we have a 1 value here to start out with a -2, so get rid of it. Or in this case where we had our 4, well, we had a -2 here, so that -2 was a prefix to the 4. So it doesn't make sense for us to start out with this -2 that we got from these two values. So we just kind of slide our index down until we find that value that doesn't have a negative prefix, and then we begin kind of enumerating all the different subarrays that can form from this value, or this starting index, which we were able to conclude was this 6 here, which in turn this ended up being our maximum subarray. So what I want you to do is I want you to take some time to try to implement in your solution to this maximum subarray problem using a dynamic programming approach. So don't use recursive solution, and if you have any questions or you get stuck, please feel free to ask them in the Q&A section, and in the next lecture we will go over my solution to this problem.